Good afternoon, everyone. Welcome to another Learn and Lunch, our webinar Wednesday webinar series for engineering with FRP and the ACMA. Today we have Locke Hey-Ho presenting, and myself, Lachlan Butcher, giving a brief introduction. We appreciate everyone joining. Currently, we've got quite a number of attendees, and we'd like to welcome any questions that you guys might have at the end of this presentation. Again, thanks. A bit of a brief introduction to Treadwell Group. We're a company that was started in 1998 in the anti-fatigue rubber matting industry. We diversified in 2008 into the range of fiberglass products. And today we find ourselves broken into 7 main product categories, which is the first product that we have is the access systems, which is the FRP grating, FRP hand railing, and the FRP structures. Just wondered if we could get the next slide there, Locke. So some of the products, obviously the hand railing for a number of different applications, but we're showing here a aquaculture project for a fish farm. Then we're moving on into the architects range of products, which is the structural profiles and structures. This is a structure that was installed at a salt farm. The next one is the EnviroTread range of products, which is our recreational public infrastructure. So for boardwalks, jetties, marinas. Then we have the EcoX range of products, which is all the odor control cover systems and baffle walling for municipal water and wastewater applications. We then have our X-Duro range of cable ladder and instrumentation management products. Our Safe Series anti-slip and retrofit anti-slip solutions. We then have our SecureX range of fencing and screening that can be used for step and touch potential applications. So that is the brief introduction to Treadwell Group. I'll now hand over to Locke Hey-Ho to go through the FRP products and the ACMA. Take us away, Locke.
Thank you, Lockie. Good afternoon, everyone. My name is Locke. Today, I will talk about how to use the ACMA standard to design some FRP structures. So before I talk about the ACMA standard, I would like to introduce you some FRP properties. First of all, FRP is an orthotropic material. Unlike steel, steel is an isotropic material, which means both directions will have the same strength, but in FRP, there will be different strength in 3 different directions. So normally, the longitudinal direction will be the strongest strength in FRP because of the continuous FRP roofings. If the stress applied on the transverse directions, normally the strength will be only like 25% comparing to the longitudinal strengths. So in transverse strengths, normally the strength is come by the resin of the FRP. So this is a brief introduction about FRP material. Now I will introduce how I actually calculate FRP structure. So currently I'm using the pre-standard done by the ACMA organization, which is for the low resistant factor design of pultruded FRP structures. So the advantage to use the LRFD is the use of multiple load and resistant factors better accounts for the different levels of uncertainty in these variables than one overall safety factor. So like doing steel or concrete design strength is too larger than the required strength. So those reduction factors or adjustment factors is controlled by several factors. First of all is the resin type, second, temperature, third, moisture, fourth, is there any chemical attack on site, fifth, time effect factors, lastly would be the failure mode of the structures. First of all, I will talk about the time effect factors. So the time effect factors will be affected by the loading type. Let's say I'm designing some pedestrian loading. Live load, I will choose 0.8 for time effect factors. If there's some impact load, I will choose 1, maybe some load that is not frequently applied on the structures. For the wind load, earthquake, the time effect factor will be 1, just like the impact load is not really frequent on the structure. Next is the moisture and temperature factor. So as I mentioned, the resin type will affect the FRP structures. So in the ACMA, there are 2 suggested resin. The first is the winding ester. The second one would be the polyester. So as you can see on the screen, winding ester have a stronger strength than the polyester material. So for the strength and elastic modulus, both have the adjustment factor. So strength will be, it will affect the tensile strength, compressive strength, or shear strength of the FRP. For elastic modulus, it will affect the diffraction. So also need to let everyone know that the temperature will affect the FRP strength. For example, if our 31, 32 degree, maybe there's no effect on the FRP structure, but if it's 40 degree, the adjustment factor will be roughly 0.86. Now I will demonstrate one example. So the post center to center is roughly 3 meters. The width of the boardwalk will be 2.4 meters. The height of the post is 0.7 meter to 1.5 meter. The live load will be roughly 3 kPa, and the window region is A1. So in the example, I choose the outer joints, the C section 152, 9.5 mil thick. The inner joints, I choose the I section 152 height, 9.5 mil thick. For the barriers, normally we will use double barriers to C section. For the post, normally we will use the square hollow section 102 times 8. Lastly is the post bracing. It's the equal leg angle 102 times 9.5 millimeter thick. So most of the cases in the FRP structure, we will use a pin connections because FRP can weld on the side. First of all, I will check diffraction on the internal joints. The reason I check diffraction is because most likely for the beam design, diffraction will be govern the design. It's more impact comparing to the ULS. So it is important to note that for when we consider the FRP diffraction, the shear deformation is important. So you will see an extra formula plus WL squared divided by AWG. This is a shear deformation. So the short-term diffraction will be roughly 11.12. So when we consider the long-term diffraction in the ACMA, there's a factor KCR, which is the long-term diffraction factor that considering the grip or strain gauge, which is a bit similar to concrete or timber. There's also a long-term diffraction factors. So if we use the SLS load combination for live load, let's say 0.6, the long-term diffraction will be roughly 9.63 millimeter. So the short-term diffraction is still higher than the long-term. Next is about the ULS check of the internal joints or beams. Let's say after you running some hand calculation or space gas model, the MU, the design moment is 3.1 kNm. normally for design a beam in ACMA, we need to check several things. The first thing would be the material ruptures. The second thing would be the local flange or web local buckling. Lastly, is also I think is quite important when we do the FRP design, is the lateral torsional buckling. So previously, people would ask me, oh, how much lateral bracing is required? In the ACMA, there's some equation that is for the I section and some closed section. For example, if I don't put any bracing or lateral torsional bracing, as you can see, the moment is just 1.6 kNm. However, if I add one extra lateral torsional bracing on the middle, and then it will become 1.5 meter effective length, the strength will become 4.3 kNm, which is not larger than 3.1 kNm. So if you have some design moment is larger than 4.3, maybe you can add extra one lateral bracing, and then you may pass the lateral torsional buckling. Second thing is we need to check the shear force, the shear strength of the internal joist. Let's say the design shear is 6.75 kN. First of all, we need to check material rupture. The second thing is we need to check the local web shear buckling. So as you can see in both, in the example, the ULS or moment on the shear and deflection is really govern the design. Step 3 is a connection design, which is very important in FRP structures. So in the ACM standard, it has some recommended end distance like E1, the edge distance, E2, as the bridge spacing between the bolt. So we need to follow the rule, sometimes 2D, 1.5D, 4D. So D is the diameter of the bolt. And there's several failure mode in FRP connections. However, today I will mainly focus on pin bearing and lead tension, because in most of the case, I would say pin bearing lead tension is the most critical failure in FRP connections. So this table is showing, let's say if you have more than one road of FRP bolt, let's say 2 or 3 bolt roads, it will tell you the proportional load on each road of bolt. So if you look at the table, there's something called materials connected, FRP or steel. So FRP or steel would be something like you're using a steel bracket with FRP member. And then you will see that the proportional of the first row with FRP steel will be higher compared with purely FRP member with member. So go back to the example. First of all, when we do the connection design, we always need to know the load directions. Like in this case, the shear force direction is applied vertically. Second thing, we need to know the members fiber directions. Let's say in this case, the inner joist, the barrel joist, both fiber direction is perpendicular to the force direction, which means when we design the connection on these two members, we need to consider transverse directions. For the FRP bracket, as you can see, the fiber direction will be parallel to the shear force directions, which means we can use the longitudinal properties. In the example, I will use double lap shear connections, which means there will be 2 equal angle on the inner joist. The reason I'm doing that is because if you just use single lap shear, which means only one bracket, it will reduce 40% of the strength based on the ACMA standard. So apply those end distance, the bridge spacing, the edge distance follow the rules. First of all, I will check the pin bearing strength in the connections on the inner joints. As you can see in the equation, it is very important to note that thickness of the members, diameter of the bolt, the direction of the fiber is very important in the connections. Second, I will check the lead tension strength. People may ask why the lead tension strength would be too small comparing with pin bearing. The reason would be because when we consider the transverse direction of the connections, as you can see, the transverse FRP tensile strength is only roughly 48.3, comparing to the longitudinal tensile strength 206.9. So that's why it's very important to know that when we design joints, when we design the bracket, when we design the post, when we design the bracing, we need to know the direction of the force and also know whether the force is applied parallel to the fiber or perpendicular to fiber, because the transverse and longitudinal strength is really make a huge difference. Lastly, I will talk about the post bracing check. In this project, let's say I'm using an equal leg angle, 101.6 times 9.5 mil thickness. The length is roughly 2.5 meter. So if in compression on the FRP members, normally we need to check the compression rupture, the compression global buckling, and compression local buckling. Normally, the global buckling will be govern the design. So as you can see, with 2.5 meter length, the strength is only roughly 10.7 kN. Also, when we design the connections of the bracing and the post, as I said, we need to know, let's say the bracing is 9.5 mil thick, and it is applied on the longitudinal direction on the equal leg angle. However, the compressive force or tensile force applied on the post will be applied on the transverse direction. If it is not parallel, if the fiber direction is not parallel to the force, we always use the transverse material strength to calculate the connections. So this is a brief example of how to use the ACMA standard to design beams, to design some connections. So this will be the end of my today presentation. If you have any question, please use our Q&A buttons to ask questions. Thank you.
That was very informative, Locke.
Thank you.
To the attendees that we've got on board, if anyone has got any questions later on or any particular projects that they're working on, by all means, feel free to reach out to us through the sales at treadwellgroup.com.au or hello@treadwellgroup.com.au. We do appreciate everyone joining. We obviously will have another webinar next Wednesday. At this point, there's been no questions back in relation to Locke's presentation, which is very informative and gone over very thoroughly. So we look forward to hearing some questions throughout the upcoming week. Thanks for everyone's time.
Thank you, everyone. See you.
Cheers.